Question A is very open-ended. What are some different quantities that are changing in this scenario? Very open-ended question. What were some of the things that you said for that?
Time.
Time.
Is one.
Okay. Others? Yeah.
Amount of water.
Amount of water. And I'm going to substitute here, if you're okay with it, the word volume. Just because that's something we would measure in cubic feet. But if we're talking about amount of water, we could also measure that amount in some other ways. What's another way besides volume that I could measure how much water is in this tank?
Height.
Sure. So we might think of the volume, let's call it capital V, right? The volume is just kind of, scientifically, it's how much water there is, measuring it on all three of those dimensions. But we could also, and it would be just as meaningful, I think, in this situation, to think about the height of the water in the tank as also being a proxy for how much water there is. In fact, if I'm describing to somebody how much water is in my swimming pool, I'm probably going to give that measurement in height as opposed to volume. Because why? Why would I do that?
It's not accurate.
Well, it's not that it's not accurate, right? I can tell somebody, I have 1.5 million liters of water in my pool. But why is that not helpful?
You can't envision it.
Right. It's because we are probably asking because we want to know whether it's safe for my 5-year-old to go wading in it, right? And so we care more about the height than we care about the volume. Not that they're not accurate. They're both accurate. But it's just one of them might have more meaning in that context than the other, right? Other quantities that might be changing here.
I feel like it's unrelated, the mass of the tank.
I don't think it's unrelated. The mass of the tank. Does that mean the mass of the tank with the water combined?
Yeah.
Okay. The mass of the, let's say, filling tank. So that includes whatever the tank is made out of and also the mass of the water that's on the inside. Okay. Sure. Why is that unrelated? So I've already sort of said that I don't think it's unrelated, but why do you feel like it's unrelated?
It's just not part of the question.
Yeah, and we don't really have any information given to us about mass, right? But we could certainly find it. Chemists in the room, what's the one piece of information that we would need here that we don't have to figure out the mass instead of the volume? Density. Density, exactly. Density is nothing more than the mass per unit volume of something. So if I know the volume and I know the density, I multiply them together, I get the mass. Right? So yeah, if we have that extra piece of information, we can also consider the mass of this filling tank. Other ideas? What else is changing here?
The volume of empty space.
Okay, yeah, volume of empty space in the tank. That's changing. Volume of empty space in tank. Okay, others? Are there quantities in this problem that are not changing?
The size of just the tank.
The size of the tank itself. So let me put this sort of in a separate category here. Not changing. The size of the tank. Okay, others? Yeah.
The rate at which the water is pouring.
The rate. Right, because that's explicitly told to us here. The rate is 0.5 cubic feet per minute. That rate is not varying, right? It's a constant rate. We turn on the tap to a certain amount, and then we just leave that tap where it is, right? The water is not speeding up. It's not slowing down. The rate of the water flow is constant. Are there others? What about the area of the surface of the water? Changing?
No,
Why not?
it's in a fixed position within the, once it reaches the boundaries of
Mhm.
the aquarium.
Oh, that's a good point. It probably is changing in the very beginning, right? As soon as the tank starts from empty, wherever my hose is placed in here, right, there's going to be a period of time in which that surface area of the water is going to grow until it reaches the sides of the container. And once it reaches the sides of the container, why doesn't it change after that? How do we know? What is it about this problem that makes that happen? It's in a glass container, but not every glass container will have the same area everywhere as they go from bottom to top. What is it about this problem that makes that true?
Its dimensions are given.
It's the shape of the tank.
Yes.
Yeah. This tank is a rectangular prism, right? Geometrically, right? What other kinds of tanks would also have that property? What other shapes could we use where the area remains the same once it starts filling, once it reaches the sides all the way up? Sure. So instead of a rectangular prism, we had a square cube, right? What else? A cylinder. Yeah. If the cross section is a circle, as long as it's the same circle at every height that we could put in there, the area is not going to change. What about a cylinder that looks like this? So I just take a cylinder at an angle. Yeah, and the area is also still the same as we go from bottom to top. So I think one of the most important parts about, so let me make this point and then we'll wrap up. One of the most important parts about pre-calculus and calculus, and I heard this happening in a couple groups, is that on the one hand, we might care about one of these quantities. Like we care about, how much water is in the tank? The problem is we can't answer that question without more information. In order to know how much water is in this tank, I have to know something else too. What else do I have to know? If you just come up to me and ask me how much water is in the tank in this problem, what else do I need to have to answer that question? What other quantity? How long the tank has been filling. Right. I don't know how much water is in the tank unless you tell me how much time it's been since the tank started filling. And so if I care about the volume of water, I must also care about time, right? And so pre-calculus and calculus are not about one quantity so much as they are about relationships between two quantities, right? Especially, we care about the kinds of relationships where if you tell me one of those quantities, I can definitely tell you the other one. If you tell me how much time has passed, I can definitely tell you, based on the information that's here, how much water is in that tank. But also, it goes the other way. If you tell me you know how much water is in the tank, I can definitely tell you how long the tank has been filling, right? How might I do that? So let's suppose that, let's suppose that I know that there's let's suppose I know that there's 16 gallons in this tank. Not gallons, cubic feet. Let's suppose I know there's 16 cubic feet in this tank. How do I know how much time has passed?
Filling at half a cubic foot.
Half a cubic foot every minute. So just do the dimensional analysis, divide by 1/2. 16 divided by half is 32. It's been filling for 32 minutes. So that relationship goes both ways, right? If you tell me one of these quantities, I can tell you the other with absolute certainty. And it's those relationships between quantities that we care about. That is what pre-calculus is. And those relationships that are deterministic, where if you tell me one, I can definitely tell you what the other one is, those relationships are called functions. And that's why we care about functions. And almost everything we study this semester is going to be functions, one way or another. So that's the preview.